In this video, we're going to look at this 2016 J2 problem, magic square. I remember when my students were doing this problem on the contest because the problem wasn't actually solving the problem, it was how to take the inputs. And depending if you're working with Java or Python, there are some different approaches you can take. And also, this is a wonderful opportunity to reinforce this function called the split function. So in this video, we're going to take a look at this and kind of talk about different ways to take the inputs and highlight this really cool data structure called lists and also two-dimensional lists. All right, so the problem description is magic squares are square arrays of numbers that have interesting properties that the numbers in each column and each row all add up to the same total. So given a 4x4 square of numbers, determine if it is a magic square. The input specifications consist of 4 lines, each having 4 spaced integers. And the output specifications either magic if the input is a magic square or not magic if the input is not a magic square. So here's our 16 inputs. You can see there's 4 lines with 4 integers on each line separated by a space. And if you add up, if you find the sum of each row and the sum of each column in this, you'll find that they're all 34, so it's magic. Same inputs, but you'll find that each row and column does not have the same total. All right, so let's take a look at this. So first thing I want to just kind of take an opportunity to talk about is a two-dimensional array or a two-dimensional list. I use those terms interchangeably right now, even though there is a difference. But you know what we have is this is a visualization of what happens here. So this is integer 1, integer 2, integer 3, integer 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And what I can do now is I think about it as having 4 rows, 1, 2, 3, 4, right? There's row 1, there's row 2, here's row 3, and here's row 4, and I have 4 columns. Column 1, which is straight down, column 2, column 3, column 4. And I really want to drive home this point of this is row 1, but it's indexed row 0. This down here is column 1, but it's indexed column 0. So this value here is row 0, column 0, row 0, column 1, row 0, column 2. This notation isn't really important for the solution I'm about to show you, but I just want to kind of introduce that notation now so that you're thinking about this, because before you know it, you're going to start dealing with multi-dimensional or two-dimensional arrays or lists. So let's just start by taking this problem. And what I've done is, this is a great problem where I've just made a variable for each input. I've given it that magic square situation. And then I've come down here and all I've done is I've said the sum of row 1 is row 0, column 0 plus row 0, column 1 plus row 0, column 2 plus row 0, column 3. So that's adding up these 4. And I basically figured out the sum of each row, the sum of each column, and I've just checked every sum against sum of row 1. So if I save this now, and I come back in here, and this is version A, and I run it, well, let's just try this again. Oh, I'm in the wrong directory, that's why. Okay, so there you go. Now I'm in the right directory. I press enter, and I get magic. And I can come in here now, and I can change one of these to be something like, 66, save this, and I run it again, and I get not magic, because now this throws one of the rows and columns doesn't match now. So this is how a student might do this if they're programming Python, and then just before they submit it, they say, okay, what I'm going to do now is I'm going to comment out this, and I'm going to take an input for every value. And what I've done is I've set up to take 16 individual inputs. And what I've done is I've taken an input, and I've cast it to an integer, and I put it in the row column 0, column 0. So I've set up my notation here. Find the sums, and I think this should work now. So let me just save this. And I'm going to run this now. And I'm going to make a really obvious magic square with all ones. So there's 1, 2, 3, 4. There's my first row. 5, 6, 7, 8. There's my second row. 9, 10, 11, 12. There's my third row. 13, 14, 15, 16. And there's my last row. And I get magic. And that's great. But if I actually submit this into the contest, it's not going to work. And the reason why is this. Let's clear this and let's run this again. If I go 1, 2, 3, 4, enter, I've actually taken a line and I've tried to cast it to an integer. And that's the problem because this input is not an integer. So how do we solve this problem? Well, it turns out if you're working in Java and you're using the scanner class and using nextInt, this problem isn't a problem because it's a smart enough function that it will distinguish between taking each integer after a return versus a space. But in Python, we have to do something a little different. And so what we do is we take advantage of the split function. This is a wonderful function. It's an instance function that can be applied to a string. And what it does is it takes that string, splits it on some special character, and produces a list. So if I take line 1 and I just take an input as a string for line 1, and then what I do is I take this value and I split it on the space, what that's going to do is it's going to take the first 4 and change it into a list. So I come down here and I'm going to say print, let's just print row 1 for now. And if I come in here now and we're going to run version B, now I can say 1, 2, 3, 4 and press enter, and there's the first inputs, and I can now use that. Now you might notice a problem here. The problem is that I have to find a sum, but these are being returned as strings, an array of strings, or a list of strings, not a list of integers. So we have to solve this problem. I'm going to show you 2 ways to do this. I'm first going to show you a shorthand that's useful. So what I can do now is I can take this shorthand here and I can say take the list row 1, and I'm going to say cast int I for I in row 1. And what this is a shorthand notation for saying I want you to take every index in the list row 1 and I want you to cast it to an int. And so if I save this now and run this, you can see I've already run it there. Let's clear this up. And I say 1, 2, 3, 4. There's my first row, and press enter. I get 1, 2, 3, 4 as integers. So now I can do all the math that I want with it. Now, though this is nice, again, as a beginning programmer, I think the bigger idea that I would want to kind of draw out here is this ability to loop through a list. So I'm going to say for I in range, and I'm going to say 0, comma, the length of line 1, comma, increase by 1, and I'm going to say, oh, that's not line 1, that should be row 1, shouldn't it? Row 1, and I'm going to say row 1 at I is equal to int row 1 at I. And that does the same thing. So what it does is it loops through every element in row 1 and casts it to an integer. And I know because the inputs have to be integers, this is going to work. Doesn't matter if you do this or you do this, but again, if you're a beginning programmer, understanding this loop structure is really useful and very important. And finally, I get this comment sometimes. People say, can I use the shorthand notation for looping through lists? Of course you can. I tend to use the longhand when I'm teaching students because it translates better to other languages and in my experience gives a better understanding. So if I come down here and I say print row 1 and row 1 and I save this, and let's give it another run. And I say 1, 2, 3, 4, and it works just as well. So what I need to do now is I need to go through this process for each of these lines. And I'm going to pause and do that quickly. So now what you can see here is that I've taken the input for the line. So I take an input, a line is a string, I split it, creating a list of strings, which is each one of those integer values. I don't need to print it anymore, so we're going to get rid of that. And I've commented out that, but the next thing I have to do is I have to cast each one of those indexes, each one of those elements to an integer. And you can see I've done that for the first case. There's my second line. Make sure all those say row 2. There's my third line. Make sure all these say row 3. There's my fourth line. Make sure they all say row 4. So now what I can do is it's exactly the same as the last problem in that I just have to kind of add up each row. So the sum of row 1 is going to be the list row 1 at index 0 plus the list row 1 at index 0, 1, 2, 3. Right? Because here's row 1, so I'm going to add this value plus that value plus that value plus that value. Row 1 at 0, 1, 2, 3. Row 2 at, this should be 0, that should be 0, that should be 0. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And so we're adding up row 1, 2, 3, 4. And now how do I get the sum of the column? Well, it's going to be row 1 at 0, row 2 at 0, row 3 at 0, row 4 at 0, which is right here. Row 1 at 0, row 2 at 0, row 3 at 0, row 4 at 0. Then row 1 at, and now we look at this line here, row 1 at 1, row 2 at 1, row 3 at 1, row 4 at 1. Then we look at this one here, row 1 at 2, row 2 at 2, row 3 at 2, row 4 at 2. And then we look at this one here, row 1 at 3, row 2 at 3, row 4 at 3, row 3 at 3, row 4 at 3. There we go. It's a mouthful. And then we do that exact same check of magic or not magic by comparing every sum against the sum of the first row. And that's how you do this problem. So again, this problem it's all about a matter of inputs and how you take the inputs and manage them. This is a really interesting problem as you get a little better. If I say, as opposed to saying that it's a 4 by 4 matrix, it could be an n by n matrix, in which case you can't hard code this by finding every sum. You have to actually use a loop. And we'll make a video to look at how to do that a little later. I hope this video helped. If you have any questions, please don't hesitate to ever reach out. Have a great day.